and he's able to assist us if we do need it. Hopefully we don't. Just a reminder on the Q&A, if you have any questions, you can either use the chat feature or the Q&A feature, or there's a raise hand. If you click that icon, it'll let Martin know and he can open up your microphone and you can ask the questions live. The webinar is titled Ask the Building Expert, so we want everybody to be able to have all your questions answered, even if it's slightly off topic. I don't mind, but feel free to ask away. And there's going to be interesting information to help building owners and boards deal with the spalling situation, which is pretty rampant around Hawaii and also in other areas of the United States that are near the ocean. Martin, I got a question.
Yes, Lance.
Are we recording?
Yes, I turned on the recording. You're recording.
Okay. Sorry. I thought I was supposed to do that. But anyway, welcome everybody. Ask the Building Expert. We're going to share some interesting information with you this morning. And the title of our webinar is Concrete Spalling Repair Guide. And we're going to give you inside information on spalling repair that people don't know. Maybe contractors know, but if you're a homeowner, condo owner, board member, property manager, you might not know this kind of stuff. So it's going to be very good. Hope you take good notes. And before I really get started, I want to let you know some facts and correct the word spelling and pronunciation of the word spalling. Spalling is spelled sort of like the word falling. It is not Spalding. Spalding is actually a brand of a basketball in sports. So be sure to pronounce it correctly. And also, please be aware of the term cement, as in, if you say, oh, look, that's a cement building, that's not really true. It's sort of true, and here's why. The fact of the matter is cement is actually a component of concrete. So to make concrete, it takes cement, which is like a powdery substance made with calcified limestone. And then you add water, sand, and gravel. So that's the recipe to make concrete. So when people say cement, it's only one element or one ingredient of concrete. Now, cement mixed with water makes mortar, and it doesn't have anything else in it. So mortar is used for making stone walls and block tile walls and different things like that, as opposed to concrete. Okay, so cement mixed with water, sand, and gravel makes concrete. And also you add reinforcing steel and whatever else is needed to construct a concrete building. So that's to just clarify the nomenclature and the terminology of the words. So let's get right into what's the main causes of spalling. Well, before I get into that, what is spalling anyway? Well, spalling is actually cracks in concrete caused by either the concrete cracking on its own, or if there's reinforcing steel, rebar, the moisture or water gets into the concrete and it gets into the rebar, or it touches the rebar, and the rebar is made of steel. So water and steel aren't very good friends. So what happens is the steel starts corroding, and Studies have shown that when the steel corrodes, it expands about 7 times the size. So when the steel expands, guess what? It causes the concrete to crack because the steel is harder than concrete. Okay, so that's what spalling is. Now, how is it caused? Well, let's take a high-rise building, uh, and it's made of concrete, and you have exposure to the elements such as rain, sun, wind, and anything uh, facts of nature. Okay, so you have constant rain, wind, sun, humidity, and different things that are factors in the building or causes of the building. Now, it doesn't cause spalling at first, but what happens is when the coating of the building starts failing, such as paint, then the water can enter the concrete because the concrete is porous. It's not waterproof. Other main causes, well, humidity, salt air, failed paint. Now, in places that are near the ocean with a lot of wind, such as Hawaii and California, San Francisco, areas of Texas, Louisiana, Florida, they all have spalling conditions that are due to salt air and wind. Now, believe it or not, there's a lot of salt in the air, and when the trade winds blow, it carries the salt from the ocean to land. And what do you have on land? You have tons of concrete buildings. So if you have a building that is fully protected and new paint on it, it's very hard for the salt and rain water to get into the concrete. If you have failed paint, such as in the photo on the right, the paint is not doing its job. So what happens is the paint starts failing and layers of paint start eroding away or disintegrating. And what happens is now you don't have full coverage of the concrete material. Okay, so it's very important that the concrete be protected. Once again, concrete is not waterproof. Um, I took chunks of concrete as an experiment and set it in little pans of water, and eventually the water soaked up into the concrete rocks that I had as a sample. So I'll give you another analogy is let's take a car. You have a nice Mercedes with new paint, and if there's a scratch on the paint that is not touched up, guess what? Where the scratch is, it starts rusting. And that's why full coverage of paint or waterproofing is the best thing for a concrete building. So how do we determine whether there's spalling of the buildings, or let's say we know there's spalling, but how do we determine like what how much spalling there is and what the cost is to repair the spalling? So there's what's called a condition survey, and the survey is a method to determine the quantities of spalls at a particular building. And there's different ways to do surveying, and it's kind of simple in one hand, and on the other hand, it may not be so simple. But the objective is to get a good snapshot of the condition of the building with respect to the various spalling conditions. So once all these spall areas are identified, those are all quantities, and we put all the quantities together, add them up, and we can determine basically what the cost is by the number of quantities for different types of spalling. So let's talk more about that. The inspection methodology to determine the um, survey condition. So the photo on the right is of a high-rise building with a lot of lanais. And one method is to just look around from the ground and look at each unit and each section of the building, and we look for cracks or peeling paint. Um, and that's called a visual inspection, which is non-destructive. We're not breaking anything or hitting anything. Also, with the visual, we can do a binocular check. We can do a inspection via drone, and we can also set up appointments with each unit owner and actually go through the unit, go under lanais, and look for cracks or spalling, check the railing, see if there's any loose railing, and conditions like that. The other method is more intrusive, and it's called sounding, and it's destructive. The reason why it's considered destructive is because we're actually using instruments such as a hammer to pound the concrete to look for spalling areas. Now, the sounding protocol is via tapping, using a hammer and tapping every square inch of the building. Um, and there's also a chain that's used, and we chain walkways and unit lanais and driveways. And that's called a chain drag method, where we're dragging a chain and listening for the difference in sound. So what happens is when we take a hammer and start pounding the concrete, we're actually listening for a difference in sound. So if the concrete is solid, you're going to hear a solid type of sound. If the concrete's hollow, uh, which is indicative of a spalling, let's say, you're going to hear sort of a more hollow type sound because there's air or space between the solid concrete and the spalled area. Also, if there's an obvious crack and you hit it with a hammer and pieces of concrete fall off, well, it's pretty obvious that it's a spall. So the sounding method is or could be very costly, because if in order to sound every square inch of the building, you're going to have to set up rigs, which is these sky climbers, and on every drop or every stack of the building, we would have to go up on the rig and start hammering away and doing our sounding. So for instance, if you have a smaller building, it could range from $35,000 for rigging and time spent. I've seen buildings at bigger buildings where if you're going to rig the building and do a sounding, it costs 100 to 200,000. And a lot of times, owners or condo boards do not want to spend that kind of money because they don't need to. And my advice to them was, if you don't need to, if you have enough money in reserve to pay for your spalling, then save that 100,000 or 50,000 that you would have used for sounding and investigation, and use it for actual spalling repair. So it just all depends on the nature of the ownership of the buildings and what they want to do and how much money they have. So those are basically the two different methods to determine spalling. So once we do our sounding, um, we have a spreadsheet, and it's listed by uh, units or unit numbers, or listed by drops. And drops is a vertical stack of the building. So let's say you have a O1 stack. So every unit is a O1 unit from the first floor all the way up to the 40th floor. So that would be stack O1, and then we list down how much spalling and what type of spalling that they have. And we'll talk about the types of spalling as we go further during the webinar. So we gather all this information and compile the results and total everything and come up with approximate number. Now, I'm not the contractor that does the work, but when I manage construction projects, I do my own estimate. So when I do get the contractor's proposals, I kind of can gauge whether they're far off or whether they're kind of within the ballpark based on what my own number is. So it's like a cross check. If I don't do that, I'm not going to have a clue whether these numbers from the contractors are correct or they're way off. Okay, so we're going to compile all the results and we're going to come up with some numbers. So right now, let's take a tour of a building to see how we gather the data on spalling concrete. So this is kind of like a field trip within a webinar. So types of spalling by location. And believe it or not, there's different locations and types of spalling. And this is where the fun comes in so that you guys know what we're talking about. And when the contractor bids, you know exactly what he's bidding on and what he's talking about. And it's not Greek and it's easy to understand. My webinar is not a technical engineering type webinar, although the same contents of this webinar could be presented in a 4-hour session at the World of Concrete show, but I made it so that it's easier to understand for the average layperson that is not into construction. So talk about spalling by location. One type is overhead and horizontal spall. If you look at the photo on the left, and these are photos of high-rise buildings, but the same locations apply regardless of whether it's a high-rise building, a low-rise building, a single-family house, a 3-story apartment building, a shopping center, or basically any type of commercial or residential building. The photo on the left is a high-rise building, and if you look at the left area at the top, almost by right at the blue sky, you're going to see areas where it's not painted and it's flat. And that's what we call overhead because it's a ceiling. Now, if the flat area was not overhead and it's horizontal, like say a lanai slab, that's considered horizontal. So overhead and horizontal basically mean the same thing. It's flat, except one is on the ground and one is above and overhead. The other type of spalling by location is a vertical spall. And instead of having it flat, whether it's a walking surface or a ceiling, it's actually a vertical surface. It's the vertical plane of the building. If you look at the photo on the right, you can see those little vertical rectangles on either side of the unit opening. Those are vertical spall repairs. And so that's the terminology of overhead, horizontal, and vertical. Now, what do you call if it's horizontal, but it's at the edge where your railing is? Okay, good question. That's called a leading edge spall. And if you look at the photo on the left, you can see the edge, and this is of a concrete balcony where the railing was removed, and you could see the edge of the slab is severely spalled. So that's what we call the leading edge. It's the edge of a walkway, uh, edge of a lanai, or it could be a roof edge. Okay. Now, there's two different types of horizontal spalls, and one is called a partial depth, and the other is called a full depth. Now, it's pretty obvious, but you take a 4-inch or 6-inch walkway concrete slab, and if the spalling repair doesn't go all the way through, in other words, it's maybe the first inch or first 2 inches of the surface, horizontal surface, that's called a partial depth repair. Why? Because it's only partial, it's not total and full. Now, if you start jackhammering away and all of a sudden it's spalled all the way through, that's called a full depth repair. And if you look at the photo on the right, that photo is a Waikiki hotel where they had severe spalling on their walkways, and it was a full depth repair. As you can see, the concrete got demolished out, and only the rebar is there. Okay, very unsafe if it gets to the point of holes where people could fall through. So naturally, a partial depth repair is cheaper to fix than a full depth repair. A partial depth repair to fix, you only need to work on the top, or maybe it's a partial depth from the bottom, from the ceiling, and it doesn't go all the way through to the top. If it's a full depth repair, you have to form the bottom with plyboard and wood framing in order to build a floor. So when you pour concrete, the concrete doesn't fall through the holes and end up on the next floor. Okay. So in addition to spalling and concrete repair, there's actually other related costs that are inherent in a spalling repair project. And for example, we have crack fills. So you have a concrete wall, like the photo on the left, it's cracked, but there's no spall. It could be a settlement crack where maybe water didn't get in, but through settlement of the ground or building, it just cracked. And the fix on that is we would have to fill it in with some filler, caulking, and sealant. There's also a rebar replacement. If you look on the photo on the right, in the middle, the rebar on this column is severely corroded, and it would require replacement. So the replacement on this rebar would have to cut it out and put a brand new piece of rebar in its place. And I'll talk to you more about rebar in a couple minutes. Also, CMU block. We have block tiles. You have a tile wall, and there's cracks in that, and it's spalled. So we would need to repair that as well. And by the way, some older apartment buildings, office buildings are made of CMU block and not solid concrete. But the spalling repair is basically treated the same way with respect to figuring out what the cost is. The method to do the spall repair is a little different on each item. I think I missed one. Okay. Additional related cost items, caulking and sealing. If you look at the photo on the left, you see that kind of gray substance between the brick and the aluminum sliding door. Okay, that's caulking, and a lot of times older buildings, that caulking gets worn away and disintegrates, and it just shrinks. And guess what? When it rains, when you have spaces there, water can get in. So we have to pay attention to that. There's railing repair. If you have steel, solid steel railing, those don't last that long, and it's so corroded where we would have to cut pieces of railing and weld a new piece in. As you can see, this is a leading edge corner of a walkway, stairway walkway. And there's, in addition to the railing, there's spalling too. So that whole section or corner of that slab landing has to be demolished out. And at the same time, um, that's when the new pieces of railing would be welded in. Now you have aluminum railing, which is not solid, it's hollow. And a lot of times the railing bases get loose and there's spalls around the base of the railing. So we have what's called a drill and fill, where we drill holes in the base of the railing and inject a filler material so that water can't build up on the base. Because what happens is, even if rain doesn't get in, over time there's humidity that builds up in different temperatures and there's condensation. So there's water actually sitting on the base of that railing post embedded in concrete. And therein lies the problem where the water starts damaging the concrete and there's spalling right at the bases. So it's pretty common to have spalls where the railing bases are, and that's where your leading edges are of your lanais. Let's talk a little bit about base bid versus unit costs. Okay, so let's say we have contractors go to our building and say, take a look at our spalls. We want to get your proposals. So the contractors, let's say you call 3 contractors, they come in, they look around, and then you get a proposal from them. Okay, beware of the lowest bidder, because it may not be as it seems. And the lowest bidder the price could be low, and that bidder could be the lowest bidder because he bid on a lower quantity than the other bidders. So common sense dictates that the low quantities result in a low bid. Okay, now I'm not saying do not take or accept the lowest bidder as your contractor. What I'm saying is to be aware of the bids. It has to be apples and oranges. It cannot be an apple and a lemon when you're comparing the bids. And this is very valuable information that contractors may not tell you. So let's say we have 2 contractor proposals, and which one is the lowest proposal? Okay, good. Someone said, oh, wait a minute. Can't you count, Lance? You said 2 contractor proposals, but you have 3. Okay, good catch. The reason why I say 2 is because contractor number 3 was too lazy and he didn't want the job, and he just arbitrarily bid high because he's too busy, and he figures that if he gets it, and he can make plenty profit. So basically, I threw that one out. So there's only 2 valid proposals. And by the way, the contractor number 3 even admitted it. He says, I don't really want the job, but instead of not turning in a bid, I just made a bid high. I know I'm not going to get it, but if I do get it, then I'll make plenty of money. Okay. Well, I said, thank you. Good attitude. So contractor 1 bid $150,000 and contractor 2 bid $250,000. So if you are the owner of the building, or you're the condo board, you're a board member of a condo, which one of these proposals would you take? Number 1 or number 2? Which is the lowest proposal? Well, naturally, the lowest proposal is number 1. Okay, so the board gets together and says, we're going to accept proposal number 1 because it's the lowest bidder. And they don't have any consultant. Okay. And then their property manager says, well, wait a minute. Do you guys actually know what a whole spalling project is like and what the components are, what needs to be done, and are you aware uh, of how the contractor is going to fix the building, and how do you know that the lowest contractor is the best contractor? And then they're going, well, you have a point there. And then somebody on the board says, are any of you board members, contractors, or engineers, or do any of you know how to estimate a spalling project, or how to inspect a spalling project, or even how to manage a spalling project? And all of them said, no, but it's easy, right? And the manager says, I think we should get bids from a consultant, a construction consultant or construction manager. Okay, so um, they contacted me, and they didn't hire me at first. They just said, we want you to come in and let us know uh, what you can do for us. And by the way, we have these 3 bids that we want you to look at and tell us why we shouldn't take the lowest bid. I said, okay, that's simple enough. So I met with them, and here's what I told them. Further analysis, after my review of the 2 bids, here's my analysis. And then, board members, you tell me what contractor you should choose before I tell you. Okay, so base bid, the contractor 1 bid 150,000. Okay, after further discussion and questioning, it was based on 1,000 square feet at $150 a square foot. And by the way, the square foot is a measurement, a 12-inch by 12-inch square of concrete on a building, and that was their estimate. Contractor number 2 bid 250,000, but it was based on 2,000 square feet times $125 a square foot. So if you look at it and think about it, contractor number 2, his price was higher, but his unit cost was lower. Contractor number 2 is basically doing twice the amount of repair work as contractor 1 at a lower unit cost. This is how you analyze a spalling proposal. Let's go down to unit costs. 200 square feet times 150 per square foot equals $30,000. The same square footage of 200 times $125 equal $25,000. So as you can see, it's better to choose the contractor that charges a lower unit cost than a base bid cost. Okay, and by the way, the unit costs of these various locations where I described above should be all listed so you can compare and you have apples to apples bidding. Okay, so in this case, the contractor that bid the lowest is not the best contractor, as you can see. So you have to quantify what the unit costs are. Because what happens is there have been cases of boards selecting the lowest contractor, but their unit cost was a lot higher. And in the end, they paid more overall than the highest contractor that bid on the job. So this is key here. This is how to really determine apples and apples and which is the best value contractor. Let's talk about concrete specifications. And this is another important factor. So you don't just have the contractor go there, chip out concrete, and then patch it with new concrete that he bought at the hardware store. That's why it's critical to have specific concrete repair specifications. There's industry standards, which is general acceptable industry standards, and there's various associations that's specific to concrete repair and concrete construction. There's American Society of Concrete Construction. There's American Concrete Institute and ACI. There's ICRI, International Concrete Repair Institute. And when I see bad concrete, I cry. If you look at the photos, um, I attended the World of Concrete show in Las Vegas a couple of years ago, and man, it was eye opener. I thought I knew everything, but I did learn a bunch of things. I've been in the concrete industry for 40 years now, and I still want to learn, and that's why I spent the money to go up there and sit in on the classes and see, what's new out there and network with other engineers in the industry. So it's key that the contractor follow the specs and don't just hire the contractor. Make sure you have specs written as far as what they're supposed to follow. Okay. In addition, and we're going into the nitty gritty now, there's a demolition and chipping protocol. And what is a protocol? Well, they don't just go and start jackhammering away. So if you look at the photo on the left, it's a photo of a leading edge with a lanai, and the railing is loose. But what I want you to learn is that if you look at the photo closely, they're ready to pour back new concrete. Now, is it saw cut to geometric shapes? No. If you look at closely on the left of that middle section, it's all not even. And so there's no way to pour new concrete back and have it really bond if you don't have an even cut. As opposed to, you look at the area on the right, to the right of that rope hanging down, and that's saw cut. So what I normally specify is the contractor mark areas that they're going to cut out and saw cut it. They don't just haphazardly start jackhammering away at everything. Also, demolition 3 inches beyond the corrosion. So if you see corroded rebar, don't stop there. You measure 3 inches from that corrosion and demo out, even if the concrete's solid, because we want a good bond. The photo on the right is of me at the World of Concrete show. I entered this contest to actually mix concrete and fill it in and smooth it out. And it was $1,000 prize. And guess what? I was second place and didn't win anything. But the guy that won turned to me and said, "Hey, good competitor. Thank you. Are you a concrete finisher?" And I said, "No, I'm an engineer. I don't even work with concrete. But I wanted to know how it's done, and I know how it's done. But of course, because I don't do it every day, I was kind of slow." And the guy was laughing, and he ended up taking me to lunch, by the way, because he was thankful. I said, "Yeah, take me to lunch. You won $1,000 cash in Las Vegas, and you didn't have to gamble. Good thing." So if you look at the photo on the right side is what mine looked like when I was partly done. So in order for me to inspect concrete, I got to be able to know how it's done. So that's the reason why I entered the contest. Well, I also wanted to win $1,000. Okay, so some more concrete repair specs. There's rebar replacement protocol. What is a protocol? When do we know when to replace the rebar? Well, if you look at the photo on the left, the rebar is like severely corroded. And usually there's, if you look at the rebar, like right at the end, and you hold it and you're looking at the end of it, that's called cross section. If you're looking right on, and if the cross section is corroded away 15% or more, that's a determination that you have to replace the entire rebar. You can't save it. Don't grind it and try to save it because you're cheap. That's not going to do it. Also, you have to remove all the corrosion on the rebar. If you look at the photo on the left, if you just use a metal grinder and grind all the rebar that you see and it's shiny, is that good enough? No, you have to chip behind the rebar so that you could go behind the rebar with a brush and apply corrosion treatment. If you do not chip behind the rebar and you just patch the top, in 2 years, the corroded rebar in the back will start spalling concrete again, and then you're back to square one. Okay. So the corrosion removal and the treatment, don't just remove the corrosion and then fill it back with concrete. You got to apply corrosion inhibitor to treat every inch of that rebar so that it doesn't get corroded again, or it takes a while for it to get corroded. Also, be sure you use the right concrete product. Just don't go to buy Quikrete at your nearest hardware store. That's not structural concrete for high-rise spalling repair. Also, the concrete coverage. If you have rebar that's sticking up too close to the surface of the concrete, that's not good enough because it's easier for water to get in. So I usually want to see a 1.5 to 2 inch concrete coverage. Sometimes you can't help it because the rebar is there already, and that's how they built the building, but we try our best. Also, curing time. If the concrete says it takes 7 days to cure, after you patch the spalling area, you don't go paint right after the second day. You have to wait until the concrete's fully cured before you apply paint. There's metal railing, how to deal with that. Also, if your building has a lot of paint that's peeling off, you have to scrape the paint off to either bare concrete or solid paint before you prime and paint. And although we're talking about concrete spalling, priming and painting has a lot to do with the success of a spalling project, because if you don't use the right primer, you don't use the right paint, you don't put enough paint on, you're going to have the same problem. It's not going to last too long. So be sure you have full coverage of the paint. If you look at the photo on the right, they're doing prime and paint. By the way, I'm not happy with that green color. It's like an army worm green. I don't like it. I don't know about you guys. Proper contract documentation. You don't just hire the contractor, he goes and fixes it, and he goes, here's the bill. Okay. So here's what you should require at every spalling project. You should require, in addition to documentation of the areas that need to be repaired, I want to see a photo beforehand, a photo during the spalling repair, and a photo after. So if you look at the photo on the left, it's obvious that there's a horizontal crack there. It's a leading edge spall right at the bases of the railing. And this is a photo as is, before any work's done. Then they started chipping out the area, and this is a close-up of the same area showing the rebar where they cleaned it up. So it looks pretty good. Okay, although there's still some concrete cracks around there, they got to dig it out some more. And then they formed it and they poured concrete. So the photo on the right is after they took out the form of the concrete, so we can see the repair. What is critical is the before and during, because the during is going to have the photo showing the condition of the actual spall area, and they have to take measurements in order for me to cross-check how much they're billing for. Okay. So in addition to taking a photo, they also need to take dimensions, length, width, depth. As you can see, there's cracks in the bricks, and it's measured. So when they do the repair, and it's a unit cost repair, they have to submit the photos and the measurements showing exactly how much concrete they use, how long, how deep, how wide. And I cross check the measurements with the photos and make sure that they're charging accordingly. Okay, this is full documentation of a spall repair. This is the right way to do it. If a contractor doesn't submit all this documentation, how do you know where they're not overcharging you if you can't prove for each spall area how much concrete they took out and how much they patched? Okay, you don't know. Also, description of location, spall type, drop number, stack number, and condo unit number. So when they're doing the repair, they need to list what the unit number was, what the type of spall. So unit 201 leading edge spall was 3 linear feet and times X amount per linear foot. And I double check all that. Um, this photo is actually of a parking stall. And what kind of spall is this? This is, right, it's a horizontal spall. And not too much concrete was chipped out, so which is good because we don't want to start digging to China. Okay, so basically, in a nutshell, that's what a whole spalling repair is like. So there's good information here. I hope you can um, use it, and appreciate you guys attending the webinar. And before I get to the question section, I want to let you know and remind you that the next webinar is about construction warranties. So there's good stuff about warranties. We talk about the different types of warranties, labor, material, the warranty claim process in a condo building and a non-condo. And that should be very interesting. Hope you guys can join us for that one. And we have some time for questions. And Martin, do we have any questions from the audience?
Oh, hey, Lance. Right now, I don't see any in the chat or in our Q&A.
Oh, okay. That's fine. I got a bunch of questions that were emailed to me prior to the webinar, and I'll just go through that list. How does that sound?
Sounds good.
Okay. So interesting. I appreciate everybody asking your questions, and as always, we're here to help. And in the future, if you have any questions about spalling or any other construction or building related questions, feel free to drop us a line, either email us or give us a call. We'll be happy to help you. The first question is, what is the typical painting cycle? And what that means is, how often should we paint the building? Well, a typical cycle is about 8 to 10 years. And basically, that means that you have to paint every 8 to 10 years. Some buildings may last longer, some may not. But if your building hasn't been painted for 15 to 20 years, you're way past the cycle. You're overdue like 2 cycles already. Um, and as I mentioned earlier, why do you need to paint? Well, you got to protect your building, and that prevents spalls. So what happens is on the cycle, let's say you paint every 10 years. The next time you paint, okay, that's when you got to do a whole spall check, repair all those spalls and paint. If you don't repair the spalls, you're going to have a major cost factor in the future, because the spalls that may cost $80,000 today, 2 years from now, it may end up costing $250,000 because it's a pyramiding type of effect. Because spalling, it doesn't heal itself. It just gets worse and worse over time. So good question. Next question is, on your past spalling projects, what has been the percentage of cost overruns? Okay, so for instance, let's say I have a building where we did a visual check for spalling, and we figured out that it was $1 million. And after we started the spalling, we used up 1 million, and we're only halfway through the building. Okay, so change order. So at the end, the spalling repair costs ended up costing 2 million, where initially we thought it was 1 million. So that's the danger of a spalling repair project. You never know what you're going to get into. Now, there have been cases where the spalling cost was 3 times more than the initial estimate. And why? Because once you start chipping away, what would look like a 6-inch crack turns out to be a 2 foot major spalling repair structural. So that's just a caveat. Interesting question. Another question. Do you recommend other types of rebar? Interesting. So this is more of an engineering building material type question. The photos I showed you was the original rebar, which is solid reinforcing steel. And the rebar is just a short term for reinforcing steel. But in addition to solid steel, there's the same type of solid steel where it's epoxy coated, and that's called an epoxy coated rebar. And lately, they came out with this fiber reinforced rebar that doesn't have any steel at all. And the plus on that one is that it doesn't rust, it doesn't corrode, and the diameter is smaller and it's lighter and it's easier to work with. So there's pros and cons for each type. And lately, I've seen a lot of fiber reinforcing rebar being used, but all over the mainland, they're still using and even in Hawaii, they're still using the original rebar. If I take a tour of Kaka'ako and look at all those new buildings going up, it's all original solid rebar. But good question. Next question. How often should a building be inspected for spalling? Okay, remember the painting question? The cycle is every 8 to 10 years. The inspection cycle of spalling is you should inspect every year. So, regardless of whether you hire a consultant or you just do it yourself, every owner of a building should have an inspection every year. Why? Because you need to know what's going on. If you don't see anything, good. If you start seeing a lot of cracks and all that, it's time to call in experts. And even if you have small spalling cracks that look minor to you, it's better to pay the price now to have it fixed, because the price is going to go up. Because guess what? If you let it go, oh, well, it's only minor, it doesn't look major. Why don't we wait, 3 years, 5 years from now, when we paint the building and fix it then? The problem you're going to have is right now to fix it, it may cost $10,000. When you wait, it's going to be a lot more. So the time would be now to get it done, and that's okay. You fix the located spall areas and you have the contractor do touch-up paint to match the building, and you're good to go. Don't ignore it and let the thing go on and on. Next question. What do you think about railing replacement? Well, I don't know really what they're asking, but um, as I mentioned before, there's different types of railing, and the idea is you want to pay attention to it now and not wait, because if the railing's loose and someone falls over, that's a definite liability and safety concern. The other thing is if you let it go too long, like the old apartment buildings in Makali, Mo'iliili, Makiki. They have those walk-up apartment buildings, and they have the 60s and 70s solid metal railing, and the railing's corroded. Okay, you want to try and fix it now, because if it gets so bad and you have to replace it, you're talking big money, thousands of dollars, because then you have to conform with today's code, railing code, safety code. If you repair it, it's grandfathered in, and it's a lot cheaper to repair old railing that it is to replace all your railing. Okay, I've seen buildings where the last railing replacement I did ended up costing $750,000. So not cheap. Okay, next question. I'm a condo board member and my building has peeling paint. How do I deal with that? Okay. The and then he asked, what is the cost? Okay, so how do you deal with peeling paint? And in the future, I'm giving a webinar on painting, but for now, how do you deal with peeling paint? You have to scrape it off to bare concrete or solid paint. So if the paint is old and when you scrape it with a metal scraper, it doesn't come off, then you can paint over it. There's what's called an adhesion test where the contractor would make X's on the paint, put special tape, and try to rip the tape off. And when he rips the tape, if the paint comes with it, then that's not solid and it needs to be addressed. If he pulls the tape off and there's no paint on it, then the paint is pretty solid. So that's the official testing protocol. And so getting back to the question, peeling paint, you have to scrape it off. And unfortunately, to peel the paint and scrape it off costs 3 times the cost of just painting the building because it's a lot of labor intensive. Can you imagine on a scaffold swing stage 40 stories above the ground having to scrape paint off on a wall of a building? That's tedious work. So that's why the cost is there. Okay, next question. What is the difference between a time and material bid versus a base bid? And okay, so on Spalling projects, you want to get a base bid and unit costs, and I rarely see a time and material bid. And why? It's because you need to track the materials, the cost of the materials, and you need to track the time. And on a T&M bid, there's normally all this extra cost, such as rigging, installing the scaffolding, installing safety barriers, blocking cars, and all these other stuff that's all added into a time and material bid. And also, if the workers are working slow, you're paying for their time to work slow. If you get a unit cost, hey, they can work as slow as they want. You're still paying the same price, except that, if they tell you it's going to take 6 months to repair the building, you don't want them to take a year because people lose their parking stalls or they have to subject themselves to the dust, noise, jackhammering, and it's just not a conducive environment to be at home listening to all that construction noise. Okay, so sometimes a T&M can work out, but for the most part, Spalling projects are not time and material. So you really got to track it good. And I have one more question. Oh, let me see. Oh, this is interesting. This is the last question. My building had spalling repair completed 3 years ago, but some areas are cracking again. What do you think? Okay, so normally I would say, well, it may be a poor job. Maybe they didn't use good concrete. Maybe they chipped away and the rebar was still corroded and they just put concrete over that. Um, Maybe they should have replaced the rebar. I mean, there's any number of things to determine. Or you know what? I said, maybe that's a spall that just came up and it wasn't an area where the contractor fixed. And the guy, I never thought about that. So what happens is you normally um, want to blame the contractor for bad work. And so this is an example of just that. And I basically told him, um, no, it may not be due to bad work. It may be these areas that just got spalled. They weren't spalled at the time of repair, but in a couple of years, these are new spalls now. So I said, if they're new spalls, you got to address it. If they're spalls where it was a previous repair by the same contractor, then you have a claim. But sometimes it could be a spall showing now that was repaired 20 years ago. So it wasn't repaired by this recent contractor, it was repaired by a previous contractor, and it's like beyond that 10-year cycle. So it just all depends. So it needs further investigation. I said, well, we need to figure out what really is going on. You can't automatically blame the contractor. It may not be his fault. So anyway, that wraps up our webinar. Hope you guys got some interesting information, and hope to see you guys at the next webinar coming up. Stay tuned, and hope to see you then. Thank you. Bye.